using the method of integration by substitution. Step by step in this subject, we will learn how to solve the integral problem by substitution. So let's start and let's see how we will do that. If we have a function that we want to be integrated, and this function is not integrable in its current state, then what we will do? We will try to put this function in another form to make it easy to integrate it. How we will do that? By using the substitution. And this will be done through assumption. Let's see some illustrative example to clarify this topic. Let's see here. Find the integral of the following function. We have this function and we will use the substitution method to solve this integral. What we will do? The first step, assumption. We'll assume u, we will take this u equal cosine x. This is the first step. Second step, derivation. We will take the derivation for our assumption. We will take the derivation in both sides, in this side and also in this side. So what is the derivative of u? It will be du. What is the derivative for cosine x? It will be minus sine x dx. Then we will multiply both sides with the negative sign. So here we will multiply, it will be sine du, and this side we will multiply it also with the negative sign. Negative sign with the negative sign, it will be positive. Why we are doing that? To get this part, because here we have sine x dx. So the sine x dx, it will be equal minus du. And why we are doing this? To get the third step of the solution. Substitution, the integration with the variable u. To substitute all the integration with the variable u. So how it will become the integral? So integral e to the power cosine x, it will be u. This part, it will be minus du. So it will be like this. The negative sign will take it outside the integral. So the integral will be integral e to the power u du. And how we will get the integral for this one? As we learned from the previous lectures. So the result of the integral exponential function, it will be the negative sign, it will be keep it as it is, e to the power u plus the constant number. The fourth step, after we calculate the integral, we substitute the value of u. We already find the integral, so later on we will substitute the value of u. Then this is the integral, it will be equal minus, this is the result of the integral, minus e to the power, what is u? We already from the first assumption, cosine x. See, we will substitute u. The value of u, it will be cosine x plus the constant number. And this is, it will be the final result. Let's see another example. Find the integral of the following function, and we will use the substitution method to solve this integral. So as we usually do, what is the first step? Assumption. We will assume u will be equal minus x to the power 2. We will take this for the assumption for u. Second step, the derivation. We will take the derivation for the both sides, the derivation for this side and for the side. What is the derivative for u? It will be du. What is the derivative for this part? It will be minus 2x dx. Later on, we will divide both sides with the number minus 2. This we will divide it by minus 2. It will be x dx. This part we will divide it also by minus 2 to get this part, x dx. To get this one, x dx. So the whole integral, it will be in terms of u. Let's see the third step, substitution in the integral with the variable u. We have this integral, Now we will put the variable u. So this part, it will be u, and x dx, it will be minus half du. X dx, it will be minus half du. So the integral, it will be, we can take the number as we learn from the properties of the integral, we can take the number outside the integral. So it will be minus half integral 3u du. And as we learn from the previous lecture how we will find the integral for this type of function, it will be the number as it is, multiply 3 to the power u divided by ln 3 plus the constant number. If you forget how to find the integral for this type of function, it is better if you review the previous lectures. The previous video, it will show you exactly how we will find the integral for this type of function. The last step, after we calculate the integral, we substitute the value of u. The final result, you just substitute the value of u. What is u? As we assumed from the first step, minus x to the power 2. Minus x to the power 2 from the assumption. So it will be, this is the final result. We just put the value of u. Let's see another example. Find the integral of the following function. We have this function, and we will find the integral by using the substitution method. Just follow the previous step and everything will be fine. We will follow the previous step. So first step, the assumption. We will take this part, we will add for the assumption. So it will be u equal x to the power 4 minus 5. Second step, we will take the derivation for the assumption. So we'll take the derivation for this side and we'll take the derivation for this side. So this the derivation for u, it will be du. What is the derivation for this part? It will be 4x to the power 3 dx, and we will divide the both sides with the number 4. We will divide it by 4, so it will be x to the power 3 dx, and this side we will divide it by 4, it will be 1 divided by 4 du. So in this case it will be x to the power 3 dx, x to the power 3 dx, it will be this part. The third step, we will just substitute the value u in the integral. So x to the power 3 dx, it will be this part. And x to the power 4 minus 5 equal what? Equal u. So we have this integral. Now the integral is become simple. It will be easy to integrate it. The number will take it outside the integral, and we have 1 integral 1 divided u du. How we will find the integral? What is the integral for this function? As we learned from the previous video and the previous lecture, it will be ln u plus, and don't forget the constant number. And later on, after we find the integral in terms of u, we will substitute the value of u. What is u? It will be x to the power 4 minus 5, and it will be the final result. Let's continue to solve more examples for the substitution method. We have here this question, find the integral of the following function. We just follow the previous step and everything will be fine. So first step, assumption. We will take this part for the assumption. So we will see it will become u equal x plus 2. This is the assumption. Second step, the derivation. We will take the derivation for our assumption. We will take the derivation for this side and this side. What is the derivative of u? It will be du. What is the derivative of this part? It will be dx. But here in this integral, we have x also. X minus 2 dx. We have x. And we want to put all the integral in the term of the variable u. So, what is the relation between x and u? This part. What we assume from the first step. So, from this part, we will get x. in term of u. So x, it will be equal u minus 2. In the third step, we will put all the integral in the term of u. So integral x, what is x? It will be x equal u minus 2, and dx equal what? Dx equal du. And this x plus 2, it will be u under the root. So now all the integral become in the term of u. Now it will be easy to find the integral. Notice that we change the sign here. After that, we will open the bracket. After we open it, we will get this result. Later on, it will be easy to find the integral, because only what we need, we will increase 1 in the exponent and we will divide it to the new exponent, as we learned from the first lectures. After we find the integral, the last step, we will substitute the value of u. What is u? U, it will be equal x plus 2. And finally, we will get the final result. And don't forget the constant number symbol. Let's see another example. We have this example. Find the integral of the following function. We will solve it by using the substitution method. As we learn, what is the first step? We will take the assumption. We will take this part for the assumption. So it will be u equal 4 minus tan x. Second step, we will take the derivation for both sides. For this side and this side. What is the derivative of u? It will be du. What is the derivative of this side? It will be minus sec square dx. And as we learn, we will multiply both sides with the negative sign to get sec square dx to get this part. Sec square dx. The third step, we will substitute the value in the term of u. So it will be integral 1. This it will be u under the root. And this part, it will be minus du. So it will be minus 1 du. Now it will be easy to find the integral. What is the integral of this one? As we learn, we will just increase 1 to the exponent and we will divide it to the new exponent. And we will get the result of this integral. The last step, we will substitute the value of what is u, what we assume from the first solution, from the first assumption. It will be 4 minus tan x plus the constant number. This is for today's lectures, and don't forget to subscribe and like for the video. And if you have any question, you can put it in the comment below, and see you next time.